All right, this is Chi Square GOF Scenario 3. So in a recent year at the 6 p.m. time slot, television channels 2, 3, 4, and 5 captured the entire audience with 30%, 25%, 20%, and 25% respectively. During the first week of the next session or season, 500 viewers were interviewed. The table records those observations. Now, I really should have said that they're randomly selected, but it didn't. So 30% watched channel TV2, 25% watched TV3, 20% watched TV4, and 25% watched TV5. That's the historical. So did the viewing preference statistically change? Well, here's what we need to do. First off, we have to total the number of viewers. Well, we know we had 500 because that's what they told us here. All right. And 30% of 500 gives me 150. 25% of 500 gives me 125. 20% is 100. And 25% again is 125. This is what we expect to happen. This is what actually happened. All right. So television audience viewers follows the historical distribution or the previous year or whatever. Television audience viewership does not follow the historical distribution. Conditions, random sample should have been given. It wasn't, so we're going to assume that it's representative. We need to have the N is less than 10%. So 500 divided by 0.1 is 5,000. And so it's reasonable to assume that there were at least 5,000 viewers across those 4 channels. All right. So at least we should have stated that. The expected values, when we look at them, they're all greater than 5. Please remember, expected values don't need to be whole numbers, but the counts do. Okay. So observed minus expected. Well, we observed 130. So we write our equation, O minus E squared over E, observed minus expected squared. Degrees of freedom, we have 1, 2, 3, 4 categories. So 4 minus 1 is 3. Please notice we're not using the sample size of 500. We're using the number of categories. So 4 minus 1 is 3. All right. And so then we can bookend it. We have 139 minus the 150 squared over 150 plus dot, 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 plus. And we have 111 minus the 125 squared over 125. So we're going to need to enter that data into the calculator. And since I haven't done it already, you can watch. It may take me a moment. Hopefully I'll get it. It won't make any errors. 139, enter. 138, enter. 112, enter. 111, enter. And then the next one is 150, enter. 125, enter. 100, enter. 125, enter. So now that I have it, I can run the test. So I'm going to go stat, test, chi squared goodness of fit, L1, L2, degrees of freedom. I have 4 categories, so 4 minus 1. 3 degrees of freedom of 3. And I end up getting a chi squared value of 5.67 with a p-value of 0.1599. That p-value is greater than our alpha, so we're going to fail to reject. So our p-value is 0.1599. We fail to reject the null. There is not sufficient evidence at alpha equal 0.10 to suggest that the television audience viewership does not follow the historical distribution. So we're not going to reject the null. The proportions have not changed, or we don't have enough to say that they have changed. All right, there's not enough evidence to say that they have changed. Once again, we have our contributions, which the calculator calculates for you at the bottom. And that's how much each of these contributed. This would be my very first one. This would be my very last one. And I look at this and I go, hey, this one contributed the most. All right, so 111 minus the 125. This was our channel 5 had the greatest contribution. So channel 2 had the least change in viewership. Channel 4 had the greatest proportion change in or greatest proportion increase in viewership. And 5 has the greatest decrease in viewership and the greatest overall change in viewership. Please remember, if I add these contributions all together, they will sum up to my chi-squared statistic of 5.67. All right, appreciate you watching. I'll see you on the next one.